Okay. Okay. All right. So the arrays are mostly, we learned about the like strings, right? Which is a single value. So let's say if I want to define a string, let's say or message, right? We would say, how are you, right? Um, but uh, hey, hi, Andy.
Hello.
Yeah, so we're just getting started. So um, let's open your console. I mean, your CodePen, and then, as usual, make sure that the behavior is not an auto-updating preview, so we can control it. Clear this. Okay, so we're going to learn about arrays. And so far we learned about the single values, right? So um, when you have strings, number, Boolean, they are single values, right? Because um, it's a single number, a single string, single true or false in a Boolean, right? But when you, in life, you'll have to have more than one values. So for example, let's say if I want to have, if I want to represent um, the items in a grocery bag, um, I cannot represent with a single value. So let's say if I have a bag, I need an array. And arrays are represented by two square brackets, opening and closing. And then inside, we can have values. So if you think of a grocery bag, I can put, let's say, milk, pen. Well, no, pen is not grocery. Onions. What else? I can't even think of chips. I don't know. Okay, so I got three things in this grocery bag, right? So this is how you can put multiple values inside a bag. Now, if you look at a physical bag, right? The physical bag has a bottom and a top, right? And then you would put the items, like when you put the first item, it always goes in the bottom, right? And then you put next item on the top, and then the last item you put is right on the top, right? Um, this is the same concept, but our bottom is actually starting from here. Think of this way, right? And then our top is here. So if I add a new item, it would go here, right? So if I want to add a new item to this bag, the way to deal with it is I would say bag dot push, and then I can add, let's say, candy. Okay, so push means add on the top, right? In this case, at the end. End is like a top in a way, right? So we are pushing candy, and it would come here, right? So let's try this. If I console log this bag, hey Jesse. Yeah, so we are learning about the arrays. So instead of having a single item, now we're going to have multiple items. And then the way to represent multiple items is using something called an array. And the arrays are represented by a square bracket. So you'll have a square bracket, and then inside you can have items. So I have milk, onions, and chips. So I have 3 items. And then I can push a new item like candy. And then if I look at the bag again, I should see milk, onion, chips, and then candy at the end. So think of this bag as this is the bottom, this is the top. So if I add any new item, it would go here. You can also think of this as a line. Like, let's say if you have a movie theater and you are standing in a line, right, for the tickets. I would put this as the ticket window, and this is the end of the line, right? So if a new person join, the new person always goes here, right, at the end of the line. So you can represent line as well, right? The reason I would say the end of the line is the easiest to get in, it's because what happens if somebody cuts the line, right? So if somebody enters here, then everyone has to move 1 step behind, right? So that requires everyone to move, right? So the easiest place to get in is at the end of the line, right? What happens is that if you think of this in terms of memory, how this is stored, this is stored in something called continuous memory. So you will have like a memory blocks, and every memory block has an address, right? So let's say there's a memory block with the address 101, right? And then there'll be a memory block with the address 102, and then 3 and 4 and so on and so forth, right? So milk is gonna go in 101, onion's gonna go in 102, chips is gonna go in 103. So you have a you know, consecutive memory in that sense, which makes sense, right? So the reason you need consecutive memory in that sense is because if I say I want to add a next value, all I have to do is, okay, if the last one is 104, the next item is going to go in 105, right? So if I mean, this is just in the internals, right? But let's say, imagine if this was in a memory 101, this is in a memory 102, and this is in a memory 103, right? Now, if I put the candy at the bottom here, then the candy goes in 104, right? But let's say if I try to insert the candy here somewhere, then the candy goes into 102, then onion has to move out of 102 and goes into 103. Chips has to move out of 103 and go into 104, right? So it disrupts everything. So if it's a continuous memory, it makes sense to always add at the bottom. I always think in terms of optimization. I mean, this information is probably not, it's beyond this class, but I always try to let you visualize this, right? This is how it works. And when you become like a higher level programmer, what happens is that, you go for an interview, they will ask you this kind of questions, right? And then, you have to explain. So this definitely helps, understanding it.
Quick question.
Sure.
So it said when in the console, it says that it's printing an object array. Is it creating a new array every time that you push something to this object, or is it
No.
creating a list?
It's creating a list. So this is how it works. When you store simple like strings or numbers, so that's a great question. So let me explain to you how it works. So let's say if I say let message equal to hi, right? So let's say if this stores in a memory call 100, right? Now, if I cannot redefine the same, I cannot do let message equal to something else, but I can replace the value. So if I do message equal to, let's say hello, what happens is it needs to reassign the memory because I've used the equal sign. Right? Equal sign is basically assign the new address. That's what it means whenever you use equal sign, right? So now it's not gonna remove a hi from that memory and put hello. Instead, it's just gonna put this in some different memory. It's the easiest way to deal with it, right? So let's say it finds a memory address 200 and puts it there, right? So this is like almost like creating a new value with the same, saving a new location, but keeping the variable name same. Okay. So because internally, as I said, it's actually storing a message equal to 100, right? Not the hi. Hi is actually stored in the memory. So 100 is stored. So what happens is that when I try to get the message out, I say, okay, where is this located? It says the memory location 100, and it goes and gets the value. Right? It doesn't really care about what the value is, right? Similarly here, message is equal to 200, so it goes and gets anything that's in the 200, right? So when you use equal sign, it reassigns it.
So it reassigns the address. So it
Yes.
doesn't overwrite what was
No.
already there. It just creates a new one and then just forgets the other one.
Exactly. So the other one is called garbage collected. So it automatically cleans the memory. Okay. However, in this case, it's the same thing in this case. Whenever you use equal sign, it has to do that. Okay. So initially I've used the equal sign. So it actually finds, let's say it found 101 as the address. Now, because it's a continuous memory, it has to only remember where the first item is stored, right? Which is the milk. After that, it knows it's a continuous memory, which means it knows that this is stored in 102, this is stored in 103, which it doesn't have to remember, right? So it remembers this address. Now, when I push this another item into the bag, this address doesn't change, right? It's still at 101. Onion is in 102, chips is in 103, and then candy goes into 104. Okay.
So if I so that sounds a lot like an array.
Yeah, this is an array.
And
Yeah.
and so usually the problem with adding things to an array
Mhm.
is like, what if there was something else in 104 already?
Mhm.
And so that's why I was assuming that it might find
Mm,
another space where it could make an array of 4.
no. So the way array works is, you know, I mean, in olden days, when you define an array, it will basically has to reserve some space, right? So let's say I have this array with 3 items, right? So it knows that how much memory it needs. So it is going to reserve that memory. And it also reserve enough memory to extend this array, right? Because this
Oh,
array
I
is
see.
extendable. So it will have access to 104, 105, and many more memory, right?
Okay, so it's
Because
not just say it's giving since it knows that it could be extended, it's
yeah,
reserving some extra space just in case.
yes, right, yeah. And I think what happens internally, just in case, if it reaches the, like, I mean, let's say if I have 1,000,000 items, if I keep adding more things, it figures it out that I need more now. I'm reaching to a point where um, I'm going to exhaust this memory. At that point, it will do something to it will have some mechanism to uh, go out of the non-linear. So it can place something, say, okay, it can break it down the array into multiple, right? So here, so internally it does all kind of, stuff, but conceptually, I would say, because it's a continuous memory and it's extendable, it needs to have, it reserve enough space.
So we're never gonna see that.
We're never gonna see that, yeah. But in our when we learn something like this, we need to understand how it works, right? Internally, it can be doing a little different than what we think, right? But when we do this, we need to understand it's a continuous memory, which it is, right? Most part. So which means that when we add something, we know that how long it's going to take, right? Because it's all about timing, how fast it is to add something. I can make this faster and slower by doing something different, right? For example, if I add something to the top of the list, everything moves, right? Just like, if somebody cuts in the line, uh, and from the beginning of the line, everyone has to move back. And imagine if there are like million lines of millions items in this array, all millions items have to move, right? So that takes some computational time. But there are solution inside an array. But what we need to remember, that always adding something at the bottom, at the end of it, it's easier. Adding something in the middle or in the front is always expensive, right? So that would kind of help us write our code in an optimal way. Okay. When I say optimal, as a somebody who's building an application, you always need to think about what's the best way to deal with it. Because what happens is that, for example, if you look at Google, if I search on something, it can give me millions of results within a second or even a millisecond, right? And inside it has this really complex way to store data and all that stuff. And it's because of this kind of thinking they are achieving this kind of stuff, right? When you go in the Google map and you say, hey, I want to go here, it can it can find you the address and it can take you there. It can find you the direction to that location within a second, right? Which is a very complex problem, but they have figured out using the right data structure to deal with it. And array is a data structure, right? So every data structure has a specific use case. And array has this use case. You can add something at the bottom. It's the easiest. Searching is also easy, right? Finding the next item is easy. So I can say, what is my next item? All I have to do is say, well, look in the next memory location, and I can find that, right? So that's easy. But if I want to search for something, I have to go visit everything. So if I say, oh, I want to find candy in this array, so I have to go and say, hey, is this candy? No, is this candy? It's, I have to go through every single element to find that. So that can be difficult, right? So every data structure has its own perks, or pros and cons, should I say? So yeah. But yeah, that's a good question, right? You always need, I would say, when when you learn programming, always be curious, right? So that's how you understand and visualize things. Okay, so now we can add something at the end of it. How do I remove something from the end? So if I want to remove something, I can say bag.pop. And remember, we're not putting anything anything inside, because when we remove something, we're not removing a specific item. We're just removing something from the end. So pop removes from the end of the array, right? This push adds to the array, the end, at the end, right? So because I pushed it and I popped it, which means if I console log in between here somewhere, I would see it, but then it would be gone, right? So let's console log in each step of the way. And if I run this, what I would see is, I would see bag with 3 items first, then the candies added, right? Because I'm console logging after this step, and then pop just removes it, candy at the end from the end. Make sense? Let's try this out. Give you a few minutes to try this out. You can add anything. I mean, it doesn't matter, candy, whatever.
If you let's say that we were to store what was popped off into a variable, and then we printed that variable, would
Yeah, great
yield-
question. Yeah, so pop actually not only pops it out, but it returns the value. So if I say what's popped, so if I print this, it would give me, you know, the value that is popped. Right? It gives you the candy. Yeah, that's a good question. Yeah, so so push it at to the end of the array, pop removes from the end of the array, and also it gives you back the value that it popped. Okay. Okay, if I want to know the length of the array, there is a simple way to find out. Console log, I can say bag dot length, and that would give me the length of the array. Let me clear this and run this again. Oh, did I make a mistake? So you can see that the length is 3, right? There are lots of different methods available for. There are lots of different methods available for you to use, and one way to look at it is this is kind of unique way. So this is, you know, this is obviously running inside a browser, right? But the CodePen actually has its own console, right? Which is different from the browser console. So browser has the main console, right? So this kind of gives you a different view. I mean, it gives you the information, but it gives you a little different view than what the browser gives you. So if I right click on the browser and if I inspect it, again, if you, it kind of messy looking thing, right? Because you need a bigger screen. But if I right click on my browser on the top here, and then click on inspect, and then there are multiple tabs here. And one of the tab is called console. And you would see the same thing here, right? One of the things you would notice here is that there is something called prototype. And if I extend it, you will see all these methods that are available for you to use on arrays. Okay. And we can look at all of them or some of them. So there is something called et, constructor, copy within entries, and so forth, right? Join. So the one we just used called pop and push. Okay. There's a slice, sort, all kind of things are available. Let's use something interesting, and length also. Let's use sort, which is one of my favorites. So if I want to use sort, let me go remove all this stuff. Let me know. I can wait if you want to, code with me. Like I will just wait for a few minutes every time. So sorting is pretty simple. You would say bag dot sort. Okay. And then what this does, I think, let me check. I think, again, because I teach so many different programming languages, sometimes I forget. Does it return something that sorts, or it sorts it inline? So yeah, it sorts it inline, which means you can see it has sorted in alphabetical order, right? So chips is first, then milk, and then onion, right? So A, B, C, D, like that, in ascending order. If you want to sort in a descending order, which means onion, milk, and chips, there is a way. So JavaScript, array sort, descending order. So there's a one called reverse. No, I think reverse just, yeah, so it's interesting. You can sort and reverse. So reverse just reverses the array. It doesn't do anything. So whichever order it is, doesn't matter. It just reverses it. So if I reverse, let's say this array, I'm just going to comment out sort for a minute, right? And if I just bag dot, yeah, you can pass also custom sort function. I'll show you in a minute. Reverse. Okay, so what reverse does, it doesn't sort. It just simply, the last element becomes the first element, right? And then the first element becomes the last element. So it just changes the order in a reverse completely, right? So if I run this, the chips become first, onion, and then milk, right? So if I want to sort, and then sort in a ascending and a descending order, right? So ascending order, we already know. By default, if I just do sort, it does in ascending order, right? But if I want to do the other way around, I can first sort, which gives me a sorted array, and I can reverse it. That just basically reverses the order as well, of sort, right? So this is how I would do, right? And then that's, so yeah, so that's onion, milk, and chips. Let's say if I have an apple here somewhere, right? So then it will be onion, milk, chips, and apple, right? Onion, milk, chips, and apple. Let's try this out. And then I'll show you if you can have a custom sort as well, right? Any questions? All right. So sort function has, I mean, this is again becomes, we haven't learned about this, so I would kind of show you, but I would suggest, I would say, you know, when it comes, we will learn about it. So for example, let's say if I have numbers, so if I have a numbers like 4, 2, let's say 7 and 1. Sorting this is very easy because there are numbers, and you would see like 7, 4, 2, 1, right? Because I sorted and then I reversed. That's cool. But what if I have this 11, 101, 112, something like this, right? If I have this, then if I sort this, it would create a problem because it doesn't sort now the right way. And the reason for this is this sort function is built to sort strings, right? So it's treating this like a string. And so you can see that it puts 7, 4, 2, and then 1 after that. And then anything that's 1, 1, 1, 0, all of this here, right? So in this case, you wanted to tell it, hey, I wanna compare this in a different way. I don't want I don't want you to treat it like a string for each element. I just treat it like a number. And there's something called callback function. And the callback function basically you can do something like this. Again, we haven't learned this yet, so that's why I'm trying to. So now it sorted it the right way, right? But if I try to explain this, it's gonna take a while, right? So I just want you to let you know that when it comes, we'll learn about this. But just remember that sorting works. Default sorting works only on strings. Number, it does some funky stuff, right? But if you really want to sort precisely, then you need to provide this callback function. Okay. Okay. So we learned about adding values, removing values. What about updating values? So let's say if I want to change this 101 to, let's say, 102, right? So usually replacing is pretty simple. You need to know where the value is, right? So let's say I need to find out what is the index of this 101, right? Because remember, this is done by location, right? So it needs to know where the address located. So let's say the first one was, let's say, memory address 101, then is 102, 103, and 104. So it removing something, replacing something from that locker, right? So in this case, the index is important. So I can access any element using an index. So the way you can access is you can say bag and then just pass the index. So let's say if I pass 0, that would give me 4 because index always starts from 0. Right? So it gives me 4, which means if I want 101, which is 0, 1, 2, 3, right? Then it would give me 101. Okay. Now, if I want to replace 101 with something else, all I have to do is bag 3 equal to 102, right? Because now I get the address of that 3. Okay. Remember, the index always starts from 0, right? Which is always one less. So if you have, let's say 1, 2, 3, 4, 5, 6, and 7 elements, because it starts from 0, the last element's index would be always one less than the length of the array, right? Which is because it's 0, 1, 2, 3, 4, 5, and 6. Okay. So whichever element you wanna replace, you just find the index, pass it in, and then just say, hey, I want a different value for this, and it gets replaced. All right, let's try this out. And I'll show you something cool as well. There are some interesting things also if you want to do with arrays. Arrays are my favorite data structure. It's the simplest data structure. It's linear, so it's easy to understand, and you can pretty much store anything inside. What if I try to replace something that doesn't exist? So this is let's say if I do 8, which doesn't exist, and I try to print back. Remember, always be curious, right? What happens? It does something really weird. You see? This last one was 6, right? And I added to something to 8, which doesn't exist. So what it's going to do? It's going to keep 7 empty because I don't have 7. And then it adds 8 with 2. So if I have, instead of, let's say if I had 80, it will fill the rest, all the middle one, with empty values. Right? And this proves that it's a continuous memory because it has to, right? If you have a continuous memory, and if I say, okay, have something in a locker number 7, and I'm going to put something in a locker 80, which means I have to reserve now everything in between, right? And I'd have to leave it empty, obviously, right? So this is how it works. So what happens if I do, let's say, try to print the 50th element, which obviously exists now, but has nothing in it? It basically it fills with something called undefined. You don't see it, but it fills with something called undefined. Undefined is an interesting one. Undefined is basically whenever you try to do something where you don't set the value, it automatically set the value undefined. It's like a placeholder, right? So yeah, that's what it does. Interesting, you don't see it here with I think this one cuts it out. Let's just see if it shows in the browser index. Yeah, I think even browser cuts off, like you can see zeros has 4 first index, so you can see the continuous memory, and then then you don't see anything in between because it doesn't, basically if you try to, so basically it is reserved, but it is not, when you try to access it, it has to return you something, so it returns undefined, which means it's empty, but it's reserved somehow. Now the length is interesting. Length has increased to 81, right? Because remember, the element starts from 0. That means it goes to 81, right? The total. Obviously, these are sort of like edge cases. You would never do this in, when you use something, but just to know that how it works. Okay. Okay, so we're gonna learn a few things, and I'm gonna give you a quick assignment to practice your skills. So the last thing we want to learn in array is so we learned about removing, updating something, and adding something, right? But we only learn about adding something at the bottom of the array. But what if you want to replace something in the beginning of any place in the array? So for that, it is possible. JavaScript allows that. So let's say if I have maybe add one more, seven numbers, and let's say I wanna let's say insert 0 in the beginning, and I want to make it look like this. Right? There is a special function. It's called splice, and it's very interesting. Sometimes it's hard to remember, but once you use it for a few times, it's like a multi-purpose function. So the way it works is you would say nums dot splice. I don't know why the name splice. And then you have to provide exactly where you want to do this activity, right? So you can add something and then remove something at the same time. So let's say I would say, oh, I want to do it at the 0th index, right? So it basically needs first parameter is index, right? The second parameter is how many items you want to remove. Okay, so let's say if I don't want to remove anything, I'm going to put 0 because I don't want to remove anything. I just want to add, right? So then for removing, you just put numbers, which means remove 5 elements, right? So if let's try removing first. So if I remove 2 elements at the 0, and then console log nums, right? You would see 1 and 2 removed, right? Because I said 0th, which is this element, and then starting this, it's removing this one and this one, 2 elements. The splice I can remove everything. Let's say remove 7 elements. It will remove pretty much everything, right? Makes it an empty array. So yeah, but in this case, let's say if I don't want to remove anything, then I'm going to put 0. So the second, as I said, number of elements to remove. And the third one is, what do I want to insert? So let's say if I want to insert 0, right? So where you want to do this, how many elements you want to remove, and how many elements you want to insert, right? So let's say if I want to insert 0 here, which means it's actually the value 0, right? This is number of elements, this is actually value 0. So now if I run this, at the 0th index, it would remove 0 element and then add 0. I can actually add something more high, let's say. Right? So this is a little bit complex, but it can let you do all kind of weird stuff in one single line. Okay, so I'm going to give you a little assignment. Make this array like this: 0, 1, and 7. Let's make this 0, 1, and 7. Oh, sorry, 0, 1, and 7. Oh, sorry, 0 and 7. Let's make this 0 and 7. Okay, what would I put in this here? So from this, I want to make it this. You can put your answer in the private chat. And again, I just console it out to see how it works, right? Sometimes the brute force work, like, brute force means, you try something. If it works, great. If it doesn't work, you try to adjust your thing, right? So here we are inserting 0 in the front, and then adding, removing all this stuff. Anyone else? So, all right. So I already know that I want to insert 0 here, right? So at index 0. So then this stays here. Then I want to remove many elements. I want to remove 1, 2, 3, 4, 5, and 6. So I'm just going to say I'm going to remove 6 element, and I'm going to add 0 at the 0th element, right? So I'm going to do this. So this actually makes it 0 and 7, right? Let me know if you have doubts here, right? Because this function is right. So All right. So as I said, you can do also multiple operations, right? So let's say if I want to achieve this, I want to remove every other elements. I want to keep 1. I want to remove 2, and then I want to have 7, right? In that case, what I need to do is I need to do it in multiple batches, right? So I would have to say, okay, from the 3 is where here, right? Which means second element, right? So I'm gonna say, oh, sorry, 2, which I want to remove. So I would say on the first element index, the 0's index, first index, right? So 2 is the first index. I want to remove 1 item, right? That would give me 1, 3, 4, 5, 6, 7, right? Now, remember, the index have changed now. So now you have to think about, now if I want to remove 4, 5, and 6, I need to start from 0, 1, and 2. So I would have to start with index 2. And then I would have to say 1, 2, 3. I need to remove 3 items, right? Right. So this how you do. But this is not the best way. If I want to remove multiple things from all over the places, then I would not use splice. Splice is simply I want to add or remove something at the same time from one location. It's the best because the index changes and then you have to really look at the numbers, re-indexed values and change, right? So okay. So that's that. What if I want to print all the values? Remember, we learned about print for loop last time, but there is an easier way to print this. There's a for loop which lets you print. So I would say for let items, or you can name whatever, num in of nums. So this, I don't have to involve any index or anything. It basically is saying, give me each number in the nums array, right? So it creates a variable called num. So it iterates through everything. And so if I simply print num, it prints every single number. This is almost like if I have, let's say, you know, how do I say? Bunch of phones, right? And I want to look at each phone. Then I would say phone of phones, right? And it just loops through all of them one by one and print it, right? This is an easiest way to get it. Another way to do this is using the traditional for loop, right? Which we learned last time. So this is where I will have to define I equal to, let's say I have to define an index, right? And then I have to say I is less than equal to nums, well, less than nums dot length, right? Because I don't want to never reach the length, because remember the last element is 1 less than the total length. and then I would say I plus plus. And in this case, I'm getting the index. So if I just print each item, I'm printing the index, not the numbers, right? Which starts from 0, not 1. So I'm printing the index, which starts from 0 and the last is 6, right? So 0, 1, 2, 3, 4, 5, and 6. And if I want to print the value, then I would have to do nums, and then I would have to pass the index. Remember, that's how you can get every single element. And if I run this, this would give me, you know, each element 1, 2, 3, 4, 5, 6, 7. So let's try this out. Any questions? I think that's all there is to learn about arrays. I mean, obviously there are so many different things that you can do with arrays, like you can combine elements, you can search inside the arrays, you can create new arrays with some values. I mean, as I said, there are lots of different functions, right? But in terms of, like the regular operation, I call it CRUD operations, right? Create, delete, what is that? Replace, add, right? So these are the operators that you need to learn, right? So now we can add anywhere in the element, in the array. We can remove it from anywhere. We can replace from anywhere. And we can access, which is printing and update from anywhere. Okay. So there is one fundamental issue with the array, or just this kind of arrays, right? So if I put, let's say, I'm going to clean, if anyone's working on this one still, I'm going to clean this up. So the issue with this part is that when I have, let's say if I have a bag, and if I have multiple items, right? As I say, water, candy, right? I'm not able to explain how much water I have or how much candy I have in this. I can say, yeah, there's some candy, there's some water. Usually when I make a list, I I usually make a list like this when I go to grocery store, because I have kind of in my head some idea of how much water I need or milk and whatnot, right? But when some people go to a grocery store, they have exactly like, oh, I need 1 gallon of milk. I need 20 candies or packet of this but specific candy, 3 bananas, whatnot, right? So if I want to represent information in that form, this is not sufficient, right? I need something more. And for that, I need something called object. Okay. So what is the difference between this and that. So the object gives you a key, which is the item, and then it gives you the value. And the way to represent the object, I'm going to call it object bag, is you use a curly brackets. And then instead of having the just the values, I'm going to have values and its quantities or something, whatever is related to that, right? Depends what you want to put. So I can say water 2. So I can separate it by column, a comma. I can say candy 3. This is nice because then, let me format this. I have key and a value. So I have 2 pieces of information. The difference between this and this, they're almost like I would say they're all almost the same in a way. Okay. Remember, we have here we have index, right? So we have a 0th index, and this is index 1. So if I were to represent this in this form, I would put something like, 0 is the water, 0th index is the water, right? And then index 1 is the candy, right? So index are kind of invisible here, but that's what this is in a way, right? That's what the bag is. So the thing about this is the numbers are unique, right? Because they're sequential. So the first is always going to be 0, second is going to be 1, and so on and so forth. But they're unique. So you would not have 1 repeating or 3 repeating, right? And it's all sequential. But in a way, I think it's the same thing. You have index, which is here, and then value, which is here, right? So if I want to access, let's say, the first element, I would say, like bag and then 0, and that gives me water, right? So I'm passing the key and I'm getting the value. In this format, the key itself is not sequential and it's not a number, though you could have a, you could have a numerical value there, but they're actually strings, right? But it also applies, the same rule apply that you cannot repeat it, right? Because then uniqueness kind of goes away. You can also access the value. So let's say if I want to get how much candy I have, then I can just pass object bag, and then I can pass candy here. And this should give me the number of candy. So it's a same concept in a way. So if I do console log, let's say, it should give me 3 candies, right? So this is important to learn the concept, right? Objects, you have key and a value, and the keys are always unique. So I cannot do again water again, right? Because it violates the rule. I think also if you make the actual list, you always have like per item, right? And if you want to have, let's say, multiple candies, and you can say, red candy or something, right? But there are different candies, right? This way I have a different key. but accessing it's exactly the same way. This is not a continuous memory because they're not sequential, which means they're stored in a unique way. Now, how is it going to be stored? It's pretty interesting. I don't want to go in that concept, but you know, if you don't store something sequentially, how would you store it, right? There's a huge algorithm that allows you to store these kind of values, and it's an instant access. So if I want to get candy, you know, it gets the candy instantly. it basically there's an encryption algorithm that takes a candy and converts into some sort of memory address, a range of a memory address, and it stores them in there, right? So then I can encrypt and decrypt. If I decrypt it, I get that key right back. And that's how it works. Again, I don't want to go into that algorithm because it's a very complex algorithm. But that's how it works. But it's an instance. This is a really cool idea, how it's stored actually. Because it's not sequential, you cannot say, you know, pop or push or anything if I want to add, right? You can just add anything anywhere because there is no like order here, right? So accessing exactly the same as I said, you pass this value and you get this value, right? But if let's say when I insert something, it's exactly the same concept. So you would just say object bag, and then you would pass, let's say, I don't know, I'm just trying to think, milk, okay, equal to 2 gallons of milk, right? And then if I print it, oops, why is it printing? I shouldn't have printed it. I always mess it up because I also teach Python, and Python has a print instead of console log. But if you print here, actually, it prints a screen. So, all right. So, yeah, it's pretty cool. You can just do this, print, and it actually prints a screen. So yeah, you can see this now. So this is very easy. In order to add something or remove something, adding is simply you just pass the key and then set the value, right? And replacing is exactly the same way, right? You can just do that. Landscape and portrait, I don't know. Let's try. What is it trying to print? Okay, it's kind of plain. It just, yeah, but now I got interested. Exactly what is it printing? So there is a CodePen demo. I don't know. I don't know what is it printing. I know that if you can print the page. Anyway, that's a different subject. I get excited when but anyway, so replacing is the same way as adding. You know, just say key and then a value. If the key exists, it replaces it. If it doesn't exist, it adds a new key and the value, right? Deleting is a little different. So for deleting, you would just say delete, and you would say this, right? You would say delete this item, and it deletes it. Well, let me print it after this. Console log back, right? Yeah. So it deleted it. So it added and it deleted right away. Okay. Yeah, let's try this out. It's pretty cool. Objects. Arrays let you, say values that are similar in nature, right? Objects let you say values that are unique. Any questions? Cool. Okay, so now the last thing in here is printing, right? How do you print all the values? So just, how we did for an array, we had this for off loop, right? The objects have something called for in loop, which is quite interesting. So you would say for, and then I can say item, let item in object bag. So basically say, give me each item, right? So it will give me all the items, not the values. So if I do console log item, it would give me each item one by one. Only the items, not the value. And if you want to get the value, then you would just, if I want the value, I would just do simply use the bag and then pass the item, right? And they should give me the value. So for array, it was off loop. This here is in loop. I don't know why they have different names. But yeah. All right. Yeah, I think we kind of cover a lot of things today. And again, if you're curious, you can always, go and look at the, let me give you some resources. This is a good resource, and I'm going to put this link here in the message, so you can check it out. I mean, it shows you sort, but you can, these are all the array methods. So for example, let's look at one by one. So let's say if you want to combine two arrays, for example, you can do it this way. So you have an array 1 and array 2, and you can say concat. So array 1 concat array 2, and it would combine them, right? You can do multiple of these same way. Don't worry about the constructor. It's we don't use constructor here anymore, so I would avoid looking at it. Copy within. So here I have like 4 items, right? So copy within, it allows you to copy. Let me show you. I'm not running. Oh yeah. So why is it not? Banana, orange, apple, mango. Banana, orange, banana, mango. So yeah, basically what it does, it's for the second element, which is apple, it copies from banana. So copy within, right? Again, these are kind of unique use cases. I think if you know, then it's a good idea, but you don't really need to. No, just ignore every, because we haven't learned about this. We will look at it later on. You can check if something is an array, right? And you can try this out as example in console log. You can just copy paste it, see how it works. What else? Reverse, we looked at it, right? We can reverse. I think pretty much it. The rest we will cover later on. Okay, so I would not worry too much about it, but yeah. If you're curious, you can always look it up. Yeah, any questions? All right, so I think that's about it. I think I don't want to cover anything more. Otherwise, your brain's gonna get filled with. But yeah, I think, as I said, have fun. Learning programming. As I said, if you make it fun, you need to be curious, right? It's not a rocket science. As I said, when I started, I hated programming. I do pretty much 8 hours of programming now and teaching and all that stuff, right? Obviously, because I have so much practice and so much knowledge, so I can do that without even thinking, right? But when I explore a new language, so I teach nowadays. I teach a language called Dart. It used in the mobile development, and 2 years ago I started learning and I started teaching it. But like if I have a gap, let's say after 1 semester, because I don't use it day-to-day basis, if I get stuck, if I go to a new semester, I have to really relearn it sometime, because if you don't use it regularly, it kind of slowly fades out from your from your memory. So the best way to learn programming is finding, or just Google stuff, and you have a playground. This is a really nice playground. I would simply just go through all these functions and just try all of these out, see what they do, right? And you'll learn about everything about arrays by just doing that. And this is probably not the best resource. So JavaScript array functions. There's some people have some creative ideas building this. Well, this is pretty interesting. So you can look at something like this, right? A lot of people have. Again, we haven't learned all of that, but you can see this is probably not the best one. Let's see. Is there a different one? Oh yeah, this is the good one. I like this one. This you know, the way they explain it is pretty interesting. Like in this example, I have all the sad faces, and then it has this map function that takes sad face and then make it smiley, and then now all the faces are smiley. It's pretty neat. And this one is filtering out all the sad faces. So, but anyway, so yeah, this is pretty interesting. Some of the stuff it's very hard to understand because we haven't actually learned. So if you see anything complex like this, kind of ignore it for now. We're gonna learn it later on. But if you see, you know, something like this, like fills, you know, fill that, you know, works, you know, because it's a simple function, right? So go over this kind of things. Yeah, I would look at this. This is pretty neat. I like the creativity of this guy. Yeah. Yeah, and then, you know, there's best way to learn is just trying and searching. Any last question? I'll give you some homework this time. I think now we are getting into the like meat of the JavaScript. So I will provide you some homework. So I'll probably give you by end of tomorrow, and then you have about 2 weeks to finish. But you know, usually when I give homework, it's pretty simple, so you can easily finish it within a half hour or 15 minutes if you know the subject very well. So don't wait too long. But yeah, and then think about final project you want to do, but ultimately, right, what application will you want to build in terms of game. Don't worry about right now. I think we'll look at it somewhere in the middle of the semester and think about it and then plan it, because we have a long semester, right? So you only need like a 1 week to finish your final project. There's a lot of learning, right? Still, so yeah. Any last question? All right. I'll see you guys next week. Have a good rest of the week and a good weekend. I hope you learned something from today, and make sure you practice.
Thank you.